All right, so cloud computing.
Yeah.
I think we can all agree it's a little overwhelming, right? It can feel like staring at this giant Lego set with no instructions.
Yeah, definitely.
You've got all these articles. You maybe even picked up the cloud at your service,
A classic.
which is a great choice.
Definitely.
But like, where do you even begin to like pull out the essential information?
Yeah, I think this deep dive is the perfect place to start because we're going to be using that book, The Cloud at Your Service, as our guide.
Perfect.
And we're going to be dissecting it, pulling out those really important points, and grounding everything in real-world examples.
Love that.
That you can relate to. And no buzzwords, no jargon overload, I promise.
Music to my ears. Chapter 1. It sets the stage, right?
It does.
Defines what cloud computing is.
Yes.
Walks us through, like, how we got here.
Yeah, and it's presented as a natural progression, right?
Yeah.
It's not just some random tech fad that popped up overnight.
Right.
It's a culmination of all these different advancements in computing over the years.
What I thought was really interesting, too, is how it really emphasizes the economic revolution that is behind all of this.
Absolutely.
It's not just about the technology.
It's about efficiency.
Right.
It's about scalability. And it's about this really radical shift from capital expenditures to operational expenditures.
Okay, explain that to me like I'm 5.
Think of it like this. You know, buying a car versus just paying for an Uber when you need it. You only pay for what you use.
Got it.
You don't have to worry about maintenance. You don't have to worry about depreciation.
Perfect.
All of those things are handled for you.
Makes a lot of sense.
So that's really the heart of it. It's that shift in the way we think about consuming computing resources.
Got it.
Yeah.
Now, something that surprised me
Okay.
was the argument that the cloud is actually more secure than traditional data centers.
I know, right?
It seems counterintuitive.
It does seem counterintuitive, but they make a really compelling case for it.
They do.
When you think about it, these cloud giants like Google and Amazon, they've invested billions of dollars in their security infrastructure.
Billions.
It's not just a side thing for them. It is their core competency. They have the expertise and the resources to build these Fort Knox-like data centers with layers upon layers of security.
Yeah, it's not just like a one-off, you know, little server rack in the back.
It's not. It's the real deal.
Wow.
And they have everything from biometric scanners to AI-powered threat detection systems.
Wow.
You know, most companies just simply can't match that level of protection on their own.
Right. Especially if you're a smaller company.
Exactly.
That's a huge point.
It is.
And something I think we should all really consider if we're worried about cloud security.
And I think a lot of people are.
Yeah.
Understandably so.
Yeah.
But when you really dig into it, you realize that the level of security that's provided by these major cloud providers is actually, in many cases, exceeding what most companies could do on their own.
Yeah, that's fascinating.
It is.
So now chapter 2
Okay.
gets into the different types of cloud services.
Yeah.
And it's almost like walking into a candy store.
It is. It is.
There's so many.
Overwhelming.
Right. You got infrastructure as a service.
Yes.
IA. You've got platform as a service. PaaS. Software as a service. SaaS. You've got private clouds. It's a whole
ecosystem.
Ecosystem, right.
It's a lot.
It's a lot to take in.
Yeah.
But the book does a great job of breaking down these models using real-world examples.
Yeah.
So, for example, for IaaS, you've got Amazon EC2, where you can basically rent virtual servers in the cloud.
Got it.
Then you've got Microsoft Azure for PaaS, which gives you this platform to build and deploy your own applications, but you don't have to manage that underlying infrastructure. And then, of course, there's SaaS, which we all use every day. Things like Google Apps or Salesforce, where the software is hosted and managed entirely in the cloud.
It's kind of amazing how they can use those really accessible examples to explain these concepts that are kind of complicated.
It can be.
They do a good job.
They do a good job of making it digestible.
Yeah, I thought so too.
And they also dive into the technology.
behind each of those models.
Yeah.
So they talk about things like virtualization, elasticity, storage, and database systems.
Yeah.
It's like giving you a peek under the hood to see how the engine actually works.
I like that analogy.
So you really get a deep understanding of what's going on.
Yeah, this is really where I thought the comparisons were helpful.
Yeah.
Because you see how each provider tackles things like APIs and resource management and programming environments.
It gives you a good sense of the different approaches and the pros and cons of each.
So it's not just about what they offer, but like how they do it.
Exactly. It's about the philosophy behind it and how that translates into the actual user experience.
Cool. All right. So chapter 3. I love this chapter because it's like, why should I care?
Right.
What's the business case for all of this?
Yeah. What's in it for me?
Right.
Why should I even bother with this cloud thing?
Yeah. And they answer it brilliantly.
They do a great job.
With a ton of examples.
Lots of real world examples.
Okay. So give me an example.
Remember Eli Lilly?
Yeah.
The pharmaceutical giant? The book talks about how they use the cloud to cut drug discovery time from months to minutes.
That's amazing.
By spinning up this massive computing cluster on demand.
That's crazy.
Like, that's the kind of agility and power that traditional IT infrastructure just cannot match.
So essentially, it's not just about cost. It's really about...
It's about innovation.
Right.
It's about speed. It's about being able to do things that you simply couldn't do before.
Got it.
And the cloud enables that.
Yeah. Wow. That's a great example.
It's a powerful example.
So what about small to medium businesses?
They talk about that too.
Okay.
They talk about how SMBs can use the cloud to level the playing field.
Okay.
They can access enterprise-grade technology without breaking the bank.
Right, because that was always the problem.
It was too expensive, too complex for smaller companies to really take advantage of these advanced technologies.
Yeah.
But the cloud changes all of that. It makes it accessible to everyone.
It's pretty amazing.
It is.
Now, they also give an example of the Washington Post using the cloud.
I love that example.
For investigative journalism.
It's fantastic.
It's a really...
It shows you the power of the cloud to do things that were previously unimaginable.
And it's not just, simple things. This is like real in-depth.
Yeah.
Like...
Serious stuff.
Serious stuff, yeah.
Yeah.
Now, I thought it was really refreshing, too, that they were really honest about where the cloud may not be the best fit.
Yeah, they're not trying to sell you on the cloud. They're trying to give you an objective view of the pros and cons. So you can make an informed decision.
Okay.
So they acknowledge that there are certain situations where the cloud might not be the best option. For example, if you have legacy systems that are really difficult to migrate to the cloud.
Got it.
Or if you have applications that require absolute real-time performance where even a millisecond of latency could be a problem.
Right.
The cloud might not be the best fit.
Got it. So it's not a
silver bullet.
One size fits all.
It's not a magic solution to every problem.
Got it.
It's a powerful tool.
Yeah.
But it's important to understand its limitations and when it's appropriate and when it's not.
Now, chapter 4 dives into security.
Everyone's favorite topic.
Yeah.
Right.
It's a big one.
It's a big one.
So I'm glad they dedicate a whole chapter to it.
Yeah, and this is where the book really digs deep to how major cloud providers address those concerns about putting your sensitive data in the cloud.
It's the question, right?
It is the question. I mean, that's the biggest barrier for a lot of companies.
Well,
I don't know if I can trust someone else with my data.
With my data.
And the book does a really good job of addressing those concerns.
Good, because that's a big one.
Yeah.
So where do they start?
Well, they start with the physical security of those data centers, which are essentially fortresses designed to withstand anything and everything you can imagine.
Like what?
We're talking layers upon layers of security.
Okay.
So you've got perimeter fences. You've got surveillance systems. You've got biometric authentication.
Oh, wow.
You've got strict access control protocols.
Yeah.
It's pretty reassuring to know that your data is physically protected at that level.
Well, it's like something out of a Mission Impossible movie, right?
It's serious business.
It's serious business.
And they've thought of everything.
Okay.
I mean, they have backup power systems. They have redundant network connections.
Okay.
They even have fire suppression systems that use inert gas instead of water. Oh, wow. Why is that?
Because water can damage
that makes sense.
servers, right?
Yeah.
So they
have really thought of everything.
They have.
And they're constantly like...
They're constantly evaluating and improving their security measures to stay ahead of those threats.
It's a lot of pressure.
It is.
To keep up with the bad guys.
It's a constant battle, but they're doing a good job.
Okay.
And they go beyond just the physical security.
Okay.
They talk about data encryption.
Okay.
They talk about access control mechanisms.
Okay.
And they talk about how cloud providers are constantly working to meet those stringent regulatory compliance requirements.
Right, because there's a lot of ARs for healthcare data, PCI DSS, for payment card information. So they have to meet all of those standards.
It's a lot to keep up with.
It's a lot to juggle, but they're doing it.
They are. And
they're doing it well.
Okay, so it's not just about keeping the bad guys out.
No.
It's also about
handling data responsibly in accordance with industry regulations.
Yeah, okay.
And they even provide step-by-step guides for setting up things like multi-factor authentication, which adds that extra layer of security to your accounts.
Got it.
And managing access keys, which control access to your cloud resources.
They're really detailed.
Very detailed. Yeah, very practical.
Yeah, okay.
So they're not just talking about it in theory. They're actually giving you the tools
that's good.
and the steps.
Now, this is where I thought the discussion of private clouds gets really interesting.
Yeah.
They present it as an alternative
option
for organizations that need even more control over their data.
Right. If you're not comfortable putting your data in a public cloud.
Yeah. And there are a lot of companies like that.
There are, for a variety of reasons.
Yeah.
So the private cloud offers that alternative.
So it's almost like
it's like having your own mini cloud.
Yeah, okay.
Right.
Right, got it.
You have all the benefits of scalability and flexibility, but within a more controlled environment.
Okay. And they give examples, right?
They do.
Of companies doing this.
They talk about Sprint using a private cloud for their fraud detection system.
Okay.
They talk about Bechtel managing massive construction projects with their own private cloud infrastructure.
Okay.
So it's really about finding that right balance between leveraging the cloud's power and meeting your specific security and compliance needs.
So you kind of have to weigh the pros and cons?
You have to weigh the pros and cons and decide what's the best fit for your particular situation.
And they even talk about hybrid approaches?
Yeah.
Like virtual private clouds?
Virtual private clouds.
VPCs.
VPCs, which are kind of like a bridge between your existing infrastructure and a public cloud.
Got it.
So you can kind of dip your toes into the cloud without going all in.
Yeah, okay.
Which can be a good strategy for organizations that are just starting their cloud journey.
God, it's like a good stepping stone.
It is.
Okay, like that.
It's a way to gradually migrate your applications and data to the cloud at a pace that's comfortable for you while maintaining that extra layer of security and control.
Got it, okay.
So it's a good option to consider.
All right, so we've covered the fundamentals of cloud computing, the different types of cloud services, the business case for it, the security aspects of it. Now, Chapter 5 gets into the nitty-gritty of actually building...
What's and designing applications.
It gets a little more technical.
Yeah, I know, but it does. Don't worry.
Don't worry.
Yeah.
The book does a fantastic job of breaking down those complex concepts into digestible chunks.
I like that.
So one of the key concepts they introduce is sharding.
Sharding, okay.
Which is essentially like splitting a giant pizza into smaller slices.
Okay.
So instead of having one massive database,
got it.
you break it down into smaller, more manageable pieces that can be distributed across multiple servers.
Okay. So kind of like divide and conquer.
Divide and conquer.
Okay.
So you can imagine if you have a huge database, it's going to be slow. It's going to be difficult to manage.
Right. Yeah.
So by breaking it down into these smaller chunks, you can improve performance and reliability.
Got it.
And they use Flickr as a real-world example, showing how they use sharding to handle their massive and ever-growing collection of photos.
Yeah.
So instead of putting all those photos in one giant database, they split them up into multiple shards.
Got it.
Each handling a subset of the data.
Okay.
And that allows them to
scale their storage capacity horizontally.
So as they grow, they just add more shards.
Add more shards. Okay. It's a very elegant solution.
Got it.
To the problem of data growth.
Okay. So sharding is for really large amounts of data.
Yes.
What about for traffic spikes?
That's where cloud bursting comes in.
Okay. Explain cloud bursting to me.
Imagine your website is suddenly flooded with traffic.
Okay. Yeah.
Like during Black Friday or a viral marketing campaign.
Yeah.
Cloud bursting allows you to dynamically expand your capacity into the cloud.
Got it.
So it's like you have this reserve army of servers that you can call upon when you need them. Yeah. So instead of having to buy and maintain all of those servers yourself.
Right, because then they just sit there.
You just pay for them when you need them. Wow, okay.
So it's a much more cost-effective solution.
Yeah. I like that.
And they talk about how eventseer.net uses cloud bursting to handle traffic surges during major events.
So they're using it all the time.
Run their application on their own servers.
Yeah.
But when they have these big events like concerts, festivals, things like that, they just burst into the cloud.
Wow.
And handle that extra load.
Wow, it's like a safety net.
It is. It's like a safety valve.
Yeah.
Right.
But it
does present some challenges.
Has some challenges, right.
Right, because now you have your application running on multiple servers in different locations. So how do you make sure that it has access to all the data?
The data.
It needs.
That's a good point.
And they discuss some solutions for that. Things like data pre-positioning and on-demand data placement.
Yeah.
So it's about thinking ahead and strategically placing your data.
Got it.
So it's readily available when and where you need it.
So it's not just about the servers.
I mean, a distributed environment.
It's about the data.
It's about the data, too.
Okay, that's a good point.
Yeah, it's an important consideration.
Okay, so we've got the databases covered. The traffic spikes covered.
Yeah.
What about storage?
Cloud storage is another game changer.
Yeah.
It offers practically unlimited capacity, host speaker.
Practically unlimited capacity. You can access it from anywhere. And it's surprisingly affordable.
Yeah, it's amazing how cheap storage has become in the cloud.
But it's not just about throwing your data into this.
Not a data dump, digital warehouse.
Right.
Right.
You have to think about how you're going to organize it, how you're going to manage it, and how you're going to protect it.
Yeah.
So the book really highlights the importance of choosing the right storage solution based on your specific needs. Right. So, for example, if you're storing just basic files like documents, images, videos, things like that, you might use a cloud storage service like Amazon S3, which is their simple storage service.
Yeah. Okay.
But if you're storing a database, you might need a different type of storage solution. Yeah. So it's really about...
So it depends on what you're doing with it.
What you're storing. Yeah. And what the requirements are.
Okay, that makes sense.
For that data.
Okay.
So let's dig into...
Amazon S3 a little bit, because you mentioned it as a good example.
It's a great example.
Cloud storage.
Probably the most popular.
Storage service.
It is a storage service.
Okay.
So explain it to me.
Out there.
Yeah, what is it?
So S3 stands for Simple Storage Service.
Simple Storage Service.
And it's basically a way to store your data in the cloud.
Okay.
And it's incredibly versatile.
Okay.
You can store practically anything in S3.
Like what?
You can store text files, images, videos, databases, you name it.
So pretty much anything.
If it's digital,
got it.
You can store it in S3.
Okay.
And they break down how it works.
Okay.
So S3 is organized into these things called buckets.
Buckets. Okay.
Which are basically like folders.
Okay.
And within those buckets, you store your objects.
Objects.
Which are the actual files or data that you're storing.
Got it.
And each object has metadata associated with it.
What's metadata?
Metadata is information about the object.
Oh, okay.
So things like its size, its creation date, the user who created it, access permissions.
So it's not the data itself, it's the information about the data.
It's data about the data.
Okay, I like that.
It's data about the data.
Okay, so it's very organized.
It's very organized. It's very structured.
Okay.
And it's designed to be highly scalable and reliable.
Now, what about those access control mechanisms?
That's a really important aspect of S3. Yeah. They have very granular access control mechanisms.
Okay.
So you can control exactly who has access to your data and what they can do with it.
Yeah.
So you can say, okay, this user can read this data.
But they can't write to it.
Okay.
Or this group of users can read and write to this data, but they can't delete it.
Got it.
Yeah. So you have a lot of flexibility in terms of how you manage access to your data.
So it's very secure.
It's very secure if you configure it properly.
Really got it.
It can make it very secure.
Now, they also talk about Amazon EBS, right?
Yes.
What is that?
Elastic Block Storage.
Elastic Block Storage. Okay.
EBS is basically like having virtual hard drives in the cloud that you can attach to your virtual servers.
Okay.
So if you're familiar with how hard drives work in a physical server, EBS is essentially the same thing.
The virtual equivalent.
But it's virtual. Okay. So you can create these virtual hard drives, store your data on them, and then attach them to your virtual servers.
Okay.
And this is really useful for things like storing operating systems, application data, databases, anything that needs to be persistent.
Okay. Persistent meaning what?
Persistent meaning that the data survives even if your server reboots.
Okay, so it's not ephemeral. It's
not like RAM where the data disappears when you turn the power off.
Got it.
This is like permanent storage.
Got it. Okay. So you've got S3 for like more basic storage, and then you've got EBS for
more specialized.
Yeah, more like critical stuff.
Yeah, more persistent.
Persistent storage.
Okay, got it.
So you have options.
Yeah.
Depending on your needs.
Now, what about the speed of accessing all this data?
That's a good question.
Because it is out there.
Somewhere in the cloud.
On your local machine.
Right.
So there is a factor of latency, which is the delay in accessing data over a network. Right. And they do address that in the book.
Okay.
They talk about the typical latency you can expect from various cloud providers, which is really helpful for making informed decisions because you don't want to choose a provider that's going to give you really slow access to your data.
If speed is a concern.
Right. If speed is important.
Right. And in a lot of cases, it is.
It is, yeah.
So they talk about things like the geographic location of the data centers.
Exactly.
Yeah.
So the closer the data center is to your users, the lower the latency is going to be.
It's almost like choosing a restaurant.
It is, yeah.
You don't want
if you're hungry,
choose a restaurant that's 2 hours away.
You don't want to wait 2 hours to get your food.
You want your data close by.
You want it close by.
Yeah.
So you can access it quickly.
All right, so we've talked about scalability, security, storage.
Yeah.
What about reliability?
Reliability.
Yeah, it's a big one.
It's a big one.
Especially when you're talking about these massive data centers.
With thousands of servers.
Yeah, with thousands of servers.
Things are going to break.
Things are going to go wrong.
Right.
So how do you build applications that can...
That's the focus of Chapter 6.
Okay.
And they start with the concept of loose coupling.
Loose coupling. Okay.
Which we touched on earlier with service-oriented architectures.
Right, SOA.
SOA.
Okay.
And it's really about designing your applications in a way that minimizes the impact of failures.
Okay.
So instead of having one giant monolithic application where everything is tightly interconnected, you break it down into smaller independent modules or services that communicate with each other through well-defined interfaces.
So it's kind of like building a house with Lego blocks.
Exactly.
Instead of pouring concrete.
Exactly.
So each block
is independent, and if one block breaks, you can easily replace it without affecting the rest of the house.
I like that.
And that's the basic idea behind loose coupling.
Got it. So it's breaking it down into
those points of failure.
Smaller chunks.
Right. So if one part fails, it doesn't bring down the whole system.
Yeah, okay.
And the book provides this really great table comparing tightly coupled versus loosely coupled applications.
Right.
And it really highlights the benefits of loose coupling.
Okay, what are they?
So you've got flexibility.
Okay.
You've got maintainability.
Okay.
And of course, reliability.
Because if something breaks.
Exactly.
Yeah.
You can just
swap it out.
Swap out that module without having to rebuild the whole system.
So it's like having...
It's like having a safety net.
A safety net for your application.
Exactly.
Okay, I like that.
And they talk about how these SOA principles really paved the way for cloud computing.
So SOA was like the...
It was kind of the precursor.
Yeah, the precursor to the cloud.
To the cloud.
Makes sense.
Yeah.
All right, so we've got the fault tolerance covered with SOA and loose coupling.
Loose coupling.
What about those really big, massive computations?
All right, so we're talking about big data.
Big data. Yeah.
Massive data sets.
Yeah.
Things that are just too big to process on a single machine.
Right. That's where MapReduce comes in.
That's where MapReduce comes in.
Okay.
It's a powerful paradigm for distributing those computations across multiple machines.
So it's kind of like...
You think of it like an army of ants carrying a heavy load.
Okay.
Each ant can only carry a small piece.
Right.
But together, they can move...
They can move mountains.
Mountains.
Right.
And that's the idea behind MapReduce. You're taking a big problem, breaking it down into smaller pieces.
Okay.
And then you're having multiple machines work on those pieces in parallel.
In parallel.
And they give a great example of sorting a petabyte of data.
A petabyte, that's
a lot of data.
A lot of data.
It's a huge amount of data.
Yeah.
But MapReduce can do that in a few hours.
That's amazing.
By spreading the work across a massive cluster of servers.
So it's like having an army of data crunching robots. Working for you.
Okay, but what happens if one of those machines crashes?
That's the beauty of MapReduce.
Okay.
It's designed to be fault tolerant.
Okay.
So if one machine fails, the other machines can pick up the slack and continue processing.
So it's like a self-healing system.
It is. It's designed to be resilient.
Yeah.
So you don't have to worry about a single point of failure.
Which is really important in the cloud.
It is because...
Yeah. Things break.
It's just a matter of when. Okay, not if.
So MapReduce is a really good solution.
It's a very elegant solution to the problem of processing big data.
Good data in the cloud.
In the cloud.
All right, so we've covered a lot of ground. We talked about different types of cloud services.
Yeah.
Building scalable and reliable applications. Chapter 7 shifts gears a little bit to the more practical aspects of working with the cloud.
The rubber meets the road.
Right.
This is where we talk about how you actually build, deploy, and manage applications in the cloud.
And they start by comparing?
They start by contrasting those traditional deployment models with their reliance on physical hardware manual processes to the more dynamic and flexible world of cloud deployment.
Okay.
It's like comparing a horse-drawn carriage.
Okay. To a self-driving car. The cloud is all about automation, scalability, and the ability to spin up and tear down resources on demand. It's a completely different paradigm.
It's not just about taking your existing applications
it's not about
putting them
in
cloud. It's about changing the way...
That's a different way of thinking.
You think about building applications.
Right.
Deploying applications and managing applications.
Okay, now one of them.
And it really empowers developers to work faster, more efficiently, and more collaboratively.
So there are big advantages for developers.
It's a big shift in the way we develop software.
And now I'm curious about the testing part of this.
Okay, testing. So testing is crucial.
It's not just about building it. You have to make sure it works.
Right.
Yeah. So they cover all sorts of different types of testing.
Like what?
So there's unit testing, where you test individual components of your application in isolation.
Okay.
Then there's functional testing, where you test how those components work together.
Got it.
Then there's visual testing, which is making sure that the application looks right, that there aren't any.
So it's not just about the back end.
Right. It's about the user interface as well.
Yeah.
Then there's load testing, where you simulate real-world traffic to see how your application performs.
Right, under pressure.
Under pressure.
Okay.
And then there's performance testing, which is just generally making sure that your application is fast and efficient.
So there's a lot of
different types of testing.
Different types of testing.
Yeah. And they all play an important role.
So ensuring
and the cloud,
the quality and reliability of your cloud applications.
And the
cloud makes it easier
to do all of this testing.
Okay, how so?
Well, for one thing, you can run tests in parallel.
Oh, okay.
So you don't have to wait.
Right, so it's much faster.
For one test to finish.
Got it.
Before you can start the next one.
Okay.
You can run multiple tests at the same time.